Okay, so this is our first lesson on fractions called equivalent fractions. So let's get started. Says Joe cut a pan of lasagna into third size pieces. Okay, so we're going to pretend that this is Joe's pan of lasagna. Okay, he cut it into third size pieces, so that means 3 pieces, all of equal size, right? Mm-hmm. Landon, hood off, please. He kept 1/3 and gave away 2/3, or gave away the rest. Joe's not going to eat his part all at once. How can he cut his part into smaller equal size pieces? So A says draw on the model to show how Joe could cut his part of the lasagna into 2 equal pieces. So they've kind of shown us right here what we're going to do. The little grid lines on this model are just to help you identify where to draw your lines. So don't let that confuse you. Okay, so here's what we're going to do. We're going to take our model and go down 1, 2, 3, 4 boxes and then draw a line right through the center. Okay? Now, instead of having, so we drew the line all the way across. So it says you can rename the 2 equal pieces as a fraction of the original pan of lasagna. So here is my, what I have now, instead of we've cut it in half, right? Right through the middle, we drew a line. So now it would look like this, right? Mm-hmm. You with me so far? So how many pieces would there be now? Shelby? 6, okay. So on this first line, we're gonna write 6. What fraction of the pan is 1 piece? Jace?
1/6.
1/6, good. Shelby and Jace, you can have a point. What fraction of the pan would be 2 pieces? Colin?
1/6.
How much is that? The whole thing, honey.
1/6.
How many 1/6 do you see?
2.
So it would actually be what?
2/6.
2/6, okay. So so it's saying basically if we started with, so Joe had 1/3 that he kept, right? And he cut that into 2 pieces. And so if we look at what, if we made that original cut all the way across the pan, now he's got 2/6 instead of 1/3. So you can rename 1/3 as 2/6. Make sure that you don't use the answer line as your fraction bar. Cash, does that make sense? Put your stuff on your table so I can see what you're doing. Okay, so 2/6. Now draw on the model to show how Joe could cut his part of the lasagna into 4 equal pieces. So we're going to go down to draw a line. Down to draw a line. Down to draw a line. And that's it, right? Because okay. So now let's count how many sections we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have 12 pieces, right?
Yep.
And so let me go back and erase these numbers. And how many of those 12 are shaded? How many are shaded? Show me on your fingers. How many are shaded? 1, 2, 3, 4 are shaded, right? 4. So first it asks what fraction of the pan is 1 piece. So how much is this 1 piece? What fraction is that? 1/12. And then, so what fraction of the pan would 4 pieces be? 4/12, right? So you guys know how I use the word thousand for a comma when we're saying big numbers?
Yep.
Okay, so when we have fractions like 1/12, you can use the words out of. So how many are shaded? 1 out of 12. That helps you remember to include every single thing as your bottom number, every single piece. Because a lot of times, guys, what kids will do is they'll write their numerators how many shaded and their denominators how many aren't shaded. Does that make sense? So they'll say this fraction would be 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8. But it's not 4 out of 8, right? It's 4 out of 12. So that out of sometimes, Waylon, are you making good choices? Okay. Here we go. So you can rename 1/3 as 4/12. So we have 2 equivalent fractions. So 1/3 could also be 2/6, right? Those are exactly the same. Or it could be 4/12. Here's a 12th, here's a 12th. Here's a 12th, here's a 12th. So all 3 of those things are exactly the same size, right? Okay. So how do you get from 1/3 to 2/6? Watch this. So I'm going to write up here my fraction line. We're going to use the words out of. Okay. So so if we wanted to make 1/3 into 2/6, we drew a line down the middle, right? Or we cut it in half. So that's turning 1 piece into 2. So we're multiplying it by 2, right? Because to get from 1 to 2, what do you multiply by?
1.
What do you multiply 1 times to get 2? 2. So if you turn that 1 piece into 4, it's the same as multiplying by 4, right? So we turned 1 piece, we times it by 4, and got 4/12, okay? So that means that 1/3 is the same as 2/6 is the same as 4/12. They're all equivalent. They're all the same, just different ways of naming the same exact amount. So whether he cuts it into 2 sections or 4 sections, it doesn't matter, right? It's still the same amount. So if one kid eats this much pizza, and this kid eats this much pizza, and this kid eats this much pizza, they all ate the same amount, right? They're just different sizes. So notice that the pieces that are smaller are half the amount of this one, right? There's twice as many of them, but they're half the size. There's 4 times as many of them, but they're 1/4 the size.
Why are they sideways?
That's just how it worked, okay? Because on 12 it was supposed to be like this, but I turned it sideways so you can see the comparison. Okay, so compare the models for 1/3 and 2/6. How does the number of parts relate to the size of the parts?
They're the same
The
number.
more parts, the smaller they are. The more parts, the smaller they are. Okay, so that's how the number of parts relates to the size of the parts. If there's more of them, they're smaller. Describe how the numerators are related and how the denominators are related, and 1/3 equals 2/6. So the numerator of this fraction is 1/3, right? The numerator of this fraction is 2/6. How do you get from 1 to 2? What do you multiply by?
2.
2. So 2 is twice as big as 1.
And then
How do
2.
you get from 3 to 6?
2.
2. If we multiply something by 2 over 2, that's the same as 1 whole, right? So that means we're not really making a change to it. When you multiply 1 times something, if you multiply 1 times 4,000, what do you get? 4,000. If you multiply 1 times 62, what do you get? 62. When you multiply 1 by something, it doesn't really change. So this is equivalent to 1, isn't it?
Yes.
So that means we're really keeping these fractions the same. We're just making them look different. We're cutting the size of the pieces smaller, but there's going to be more of them. Okay? So, let's see, the numerator and denominator in 2/6 is twice, no, let's do 2 times as many as, is 2 times as many as the numerator and denominator in 1/3. The numerator and denominator in 1/3. The numerator and denominator in 2/6 is twice as many as the numerator and denominator in 1/3. Fractions are a little bit abstract. It's they get a little bit confusing. So I do have fraction tiles. I have enough for everybody to have a set when we're doing math. Not to play with, but to learn with. Yes, Jace?
Could you add more to the fractions or no?
Absolutely. As long as you multiply the top and the bottom by the same number. So here's what I'm going to tell you. You guys know my saying where I say, when we're doing long division, my saying, look to the left, circle, go up, circle, right? You've heard me say that like a million times, right?
Yes, very much so.
So here's my new thing you're going to hear me say all the time. If you do it to the top, you do it to the bottom. Or if you do it to the bottom, you do it to the top. And what I mean by that is you guys know 1/2 pretty well, right?
Yeah.
You guys know 1/2 is half of something. Okay? That's one that you guys you do automatically, okay? It's kind of a natural thing. So if you've got a candy bar and you want to split it with somebody, you break it in half, right? So, but Jace's question is, can we go even higher, right, Jace? Is that what you're asking? Mm-hmm. So if we want to cut each half,
That would
cut one of these into 50 times as many pieces. So maybe we want to split it with 50 kids, okay? Let's pretend this is great big and we want to split it with 50 kids. Just hand those and go. Okay. Just have a seat, Jace. We'll,
I'll give them to him.
thank you. Okay. So, if we want to cut our 1/2 into 50 to feed 50 kids, it doesn't have to be this small. It could be a great big 1/2, just as long as it's half. We would multiply times 50 on top, and if we do it to the top,
You do
do
it
it to the bottom. 50 over 50. So what is 1 times 50?
50.
50. What is 2 times 50?
100.
Is 50 1/2 of 100?
Yes.
Do you see how this works? So what you're going to do is multiply, Cash, the numerator, the top number, and the denominator by the same number. And that will get you equivalent fractions. Okay, let's keep going. Does 1/3 equal 3/9? Or are those equivalent? So, this is 1/3, right? 1/3 is going to be this model, right? That section? Is that 1/3? Yep, have a seat so everybody behind you can see. Is this 1/3 that I've shaded?
No.
Okay. 1 out of 3 are shaded, right?
Because it would be 2/3
Now
if you
watch
didn't
this.
have that other one.
Watch this. Now I'm going to draw lines. How many sections do I have now? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 sections now, and how many are shaded?
3/9.
1, 2,
3 out of
3.
9.
So is 1/3 equivalent to 3/9?
Yes.
Yes. Because, and we can check it by doing this. What do you multiply 1 times to get 3?
3.
3, and if you do it to the top,
You do it to the bottom. If you do it to the
And-
bottom, you do it to your top.
both. Okay, but in this case, we're starting with the top. So, if you multiply, listen, sit. People cannot see. Sit on your pockets in your chair. Okay? 1 times 3 is 3, and 3 times 3 is 9. So 1/3 is equivalent to 3/9 because the number that you multiply together, or the number that you multiply 1 times to get 3 and 3 times to get 9 is the same. Okay, does 1/3 equal 3/9? Yes, because three is 3 times as many as 1. And 9 is 3 times as many as 3. Whose voice am I hearing?
Waylon's.
Waylon, you need to be quiet. Okay. Yes, because 3 is 3 times as many as 1, and 9 is 3 times as many as 3. So in other words, this number is the same on top and bottom. Okay, so we multiply by the same thing to get the 3/9. All right, I'll give you a second to write that.
Why does it say 3 times as many as 3?
What, Dakota?
It says 3 times as many as 3.
Yes, because 3 is 3 times as many as 1, and 9 is 3 times as many as 3. So we multiply the 1
No,
times
it's
3.
on the bottom line is what he's talking about. There's 2 many as 3. Like, as many as
3 times as many as, oh, I see what you're saying. Yeah. I'm trying to talk and write at the same time. It's not always easy. Okay. It's never easy. And 9 is 3 times as many as 3. Okay. Thank you for pointing that out. All right. So Savannah has 2/4 yard of ribbon, and Isabel has 3/8. How can you determine whether Savannah and Isabel have the same length of ribbon? So we're trying to figure out who has more. One of the girls has 2/4, and the other girl has 3/8. Trying to remember what color 8s are.
Something like green.
Honey. You may not have 8.
I'm sure you have 8 since you did the other 2 classes.
There they are, they're blue. Okay. So, and then the other girl has 3/8. All right, so. Who has more? Let's do this. Let's do it like this. Do they have the same amount?
No.
No. Okay. So that's a visual, but look at another way. If you don't have these, what you can do is draw, use a model. So we're going to, whose voice am I hearing?
Dakota.
Who?
Dakota.
You guys need to be listening. Okay, 2/4 is shaded there. And how much am I going to shade on the next one?
3/8.
3/8. Okay. And 2/4 is half, right? And 4/8 is half, so 3/8 is less than 4/8. So are 2/4 and 3/8 equal?
No.
No. So here's the new symbol. You guys know the symbol that I've taught you that means about?
Yeah.
Okay, here's a new symbol for you today. Not equivalent. Or not equal. Okay, so it's an equal sign with a line through it. That means not equivalent. So we're going to draw that now. The equal sign with a line through it. Not equivalent. 2/4 and 3/8 are not equivalent. Okay. Everybody get that down?
Also, when you think about it, that symbol is also like 2 plus signs.
Nope, it's an equal sign with a line through it. Okay. Use the model to write an equivalent fraction. So they've started with 1/5. And we're going to draw a line right smack down the middle. And now, let's count the number of sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 sections, 10 will be our denominator. What will be our numerator? Waylon, what will be our numerator? Cash?
2.
2. Good job. Cash, give yourself a point. Okay. All right. So 2/10. So it's easy to see with a model, but look, if we have 1/5 and we're trying to figure out what the equivalent fraction is, what is 1 times 2?
2.
And 5 times 2?
10.
10. So 1/5 and 2/10 are equivalent. We just doubled the number of pieces, but made them half as big. All right, so here we have 2/3 shaded. There's 1/3, 2/3 shaded. And over here, we're going to draw a line down the middle again, but this way. And now, how many sections do we have?
2.
1, 2, 3, 4,
6.
5, 6. And how many are shaded?
4 out of 6.
4 out of 6. Good. Okay, and we can check and make sure that we got it right by saying 2/3 and 4/6. What do you multiply 2 times to get 4?
2.
If you don't know your facts good, let me show you how to do that. Go to the 2 row, find 4, go up. Go to the 2 row, find 4, go up. What do you multiply 2 times to get 4?
2.
And if you do it to the top?
Do it to the bottom.
And what is 3 times 2?
6.
6. So 2/3 and 4/6 are equivalent. All right, next, 1/6 and 2/12. So here's how we're going to do these. We're going to ask ourselves questions. Dakota, sit down so Waylon can see. 1/6 and 2/12. Okay. So, Ella, what do you multiply 1 times to get 2? 2. And if you do it to the top?
You do it to the bottom.
And what is 6 times 2?
12.
So 1/6 and 2/12 are equivalent. It won't always work like that. Let's look at this one. 2/5 and 6/10. What do you multiply 2 times to get 6, Sophie? What do you multiply 2 times to get 6? 3. And if you do it to the top?
Do it to the bottom.
And what is 5 times 3?
15.
Oh, this is 10. So guess what?
It's not.
Not equivalent.
So you put the little equal sign with a line through it.
Okay.
Got it.
All right. On the next one, they gave us the bigger numbers first. So we're just going to start over here and say, what do you multiply 1 times to get 4?
4.
4. And if you do it to the top?
Do it to the bottom.
And what is 3 times 4?
12.
So they are equivalent. I have a lot of students in the past that we've gone through all the examples. Then when they get on their own, they're like, I don't know what to do. Remember, ask yourself, what do I multiply the smaller number times to get the bigger number? Okay, that's what the question you're going to ask. Okay, now we have 5/8 and 2/4. Okay, 5/8 and 2/4. What do we multiply 2 times to get 5? There's nothing you can multiply 2 times to get 5, right?
So it's not equivalent.
Not equivalent.
That's easy.
Yep. And you can check and say, well, what do we multiply 4 times to get 8?
Nothing.
2. You can do the bottom one. What do you multiply 4 times to get 8? 2. 2 times 2 is not 5. Okay. What do you multiply 5 times to get 10? Zing. What do you multiply 5 times to get 10? 2. And if you do it to the top?
You do it to the bottom.
What is 6 times 2?
12.
12. So they are equivalent. Okay, think about this one. What's half of 2?
1.
What's half of 10?
5.
Both of those fractions represent a half.
Equal.
So they are equivalent. You can check by saying, what do you multiply 1 times to get 5?
5.
And what is 2 times 5? 10. Okay. All right, it says Manny used 8 size parts to model, 8 tenth size parts. Scratch that. 8 tenth size parts to model 8 tenths. Okay, so this is what he had. He had 8 of the purples. So let me get 8 purples. Tenths, tenths, tenths. Some of these are different, a little different color than the others because they came from different sets. Okay, 1/10, 1/10. How many tenths did he have? 8. Okay. All right, 1/10. Okay, so he had 8 tenths, right? And Anna used fewer parts to model an equivalent fraction. So, what could Anna have used if he used tenths? What could Anna have used to model 8 tenths? Well, she used fewer, so that means we're going to divide. And what is something you can divide 10 by? What can you divide 10 by, Ethan? 2. And we know that because 10 is an even number. So let's look at that. If we divide 8 by 2, what do we get? Ethan? 4. And if we divide 10 by 2, what do we get? 5. 4/5. So let's try that. This one's a little tricky. Is this the same size as the purple? Is the green the same size? Yeah. So here we go. So Anna used fewer parts to model an equivalent fraction. How does the size of the part in Anna's model compare to the size of a 10th size part? Anna's parts are twice as large. Or twice as big as Manny's. Okay, Anna's parts are twice as big as Manny's. And then it says, what size part did Anna use? She used 5th size parts. 5th size parts. Okay, that's what hers are. It doesn't ask what's the equivalent, it just says what's the size of them. These are 5th size, right? Okay, the last one we're gonna do, how many 8 size parts do you need to make 3/4? So, we have 3/4. Here's my 3/4. This is our last one we're doing together, 3/4. How many 8 size parts will you need? Well, let's look at how many 8ths it takes to make one of these. Julie, how many 8 size parts does it take to make 1/4? 2. So if we need 2 for this one, 2 for this one, and 2 for this one, how many 8ths will that be, Sonia? You need 2 for this one, 2 for this one, and 2 for this one. Huh? Count the blue one, Sonia. 6 8ths. Okay? So how many 8 size parts do you need to model 3/4? 6. Because 1/4 equals 2 8ths. So 3/4 equals 6 8ths. In other words, for every one of these, you have 2 of these. So if you have 3 of these, you have to go 2, 4, 6. Okay. You guys, your assignment is the back side. Okay, that's it for the video.